Now for the final part of our first Math 30-1 lesson, we're going to be looking at building a number, but this time with a twist. So we have some restrictions. How many possible 6-digit even numbers are there if no digits are allowed to repeat? It's actually the forbidding of repetitions that complicates this problem. So we are still going to have 6 possible digits. Now initially we might jump to the idea and say, hey, we've got 5 possibilities for our last digit because it's still an even number. And then we say, well, we've solved this before. We knew there were 9 digits up here. This is a trap. It is a very easy mistake to make because we actually have an OR situation here. If we've got 5 digits to pick from here, remember these 5 digits are 0, 2, 4, 6, and 8. Now we know 0 is not allowed in the first digit. That's why we had 9. But now digits are not allowed to repeat. So if this last digit is any of these 4, the 2, 4, 6, or 8, we don't have 9 options up here anymore. We only have 8 options. For example, if we pick 2 for our last digit, then our first digit is not allowed to be 0 or 2. Both of these numbers have been removed from the list of options. So we have to deal with this in 2 cases. Different cases show up frequently in math. So we are going to have the case where this last digit is not 0, or we are going to have the case where the last digit is 0. If it is 0, we have 1 option for filling in that blank and 9 options left for our first blank. If the last digit is not going to be 0, there are 4 even digits to pick from, 2, 4, 6, or 8, but now only 8 digits to pick from for the first digit, because it can't be 0 and it can't be whatever we picked for our last digit. So these are 2 of the fundamental differences here. Now that we have these established, we can fill in these 4 blanks in the middle. Now this is why we didn't want to jump to filling them in first in our last situation. We need to go through the cases and see if they really are unrestricted or if other restrictions appear as we're going through. When we're not allowed to repeat, we do have other restrictions. So for example, with these 4 blanks, we can have 8 options left for the first, because this is allowed to be 0. We can't have a 0 here. We know we don't have a 0 here. So we're not allowed to pick the first digit or the last digit, but 0 is allowed. Now we have 3 digits chosen. There's only 7 options left here. 4 digits chosen leaves 6 options here, and then 5 options there. And these numbers are going to get multiplied together. We can use virtually identical logic to put that same 8, 6, 7, 5 in the middle here. So this actually leads us to 2 numbers that need to be combined. 53,760 options that do not end in 0, and 15,120 options that do end in 0, for a total of 68,880 6-digit even numbers with no repeating digits. So these 8 examples cover a lot of the possible examples that you are going to see. It's not completely comprehensive. You may have cases where someone asks you to build a 5-digit number where all digits are in descending order. Well, that is going to be a little more complicated. It's actually easier to use one of the later topics that we're going to see in lesson 1.03. But this will cover most of the fundamental counting principle questions that are going to arise in a typical course. Our next lesson will be lesson 1.02, dealing with permutations.